Okay, in this presentation we are going to look at continuous random variables. Here we have the continuous random variable x, and it has the probability density function given by this value here, or this expression here, k times x squared times 1 minus x to be squared, and it is valid in the range of values between 0 and 1 inclusive. Now, first thing we have to do is find the value of k. Okay, so what we're going to do here is first off, actually, what I'm going to do is just re-express that expression there as kx squared times 1 minus 2x plus x squared. In fact, I might even go further than that and express it as k times x squared, x squared minus 2x cubed plus x to the power of 4 later on. Okay, sorry, that's in brackets there. Okay, so I'm going to be integrating that. Oh, actually, here's where I discussed integration already. The total area under the probability density function is 1 between the upper and lower limits. So essentially, if you integrate it, it's a definite integral. Okay, where you integrate the PDF there between the upper and lower limits. Here, those upper and lower limits are what we are told in the question, 0 and 1. And when we get an answer, it should equal to 1. So let's do that. So here's our area there, and we know it's going to equal to 1. So this is our expression here, kx squared times 1 minus 2x plus x squared. Okay. Now previously I called this, essentially what we're going to do is take the k out here. So this k here, we're just going to put it out here permanently. Okay. Okay, so essentially what we're going to do is just integrate that part there. So it's x squared times 1 minus 2x plus x squared, which will become x squared minus 2x cubed plus x to the power of 4. Okay, so when we integrate x squared, we get 1/3 of x cubed. When we integrate minus 2x cubed, we get 2/4 times x to the power of 4. Okay, and so essentially that's 2/4, which just becomes 1/2. And this is x to the power of 4 here. So we integrate x to the power of 4, we get 1/5 times x to the power of 5. And this is a definite integral. So what we have there are our upper and lower limits, 1 and 0. So essentially we just evaluated the whole way through. I've just done it there to flesh it out properly. I'm not going to do this very often, but just to sort of state that this is a definite integral. Okay, so when we evaluate x squared at 1, we get 1, and when we evaluate x squared at 0, we get 0. And so it's 1/3 minus 0 minus 1/2 minus 0 plus 1/5 minus 0. So just tidy that up. Let's just sort of make it easier to evaluate. We would get 10/30 minus 15/30 plus 6/30. Okay, and working that out, we would get 1/30. Okay, so k times 1/30 is equal to 1. Necessarily, k is equal to 30. Okay, now here's a little graph of how that would look. So here we have 0, here we have 1. So this is what happens if you plot the curve. Now, historically, essentially what you might be asked to do is sketch these out. I'm not going to sketch them out. So just to sort of state that, you know, your curve should look like this if you are going to still are asked to sketch it out. So it's a quadratic expression, so that's what quadratic expressions look like. So there is a little bit of OR code at the end. I actually rendered this using a programming language called OR. I didn't really break my back doing it either, so it's just a very simple plot, and I'll show you the OR code at the end. So that's the first question there. So essentially what we have to do now is calculate the expected value of x and the variance of x. Okay, now the expected value of x is essentially very similar to what we've done there previously for calculating the area, but just that rather than integrating x, we integrate, or f of x, we integrate x times f of x. That's the only difference there. Okay, so it's essentially a definite integral again. Okay, so this time we have x times x squared times our expression. So it's 1 power more, essentially. So essentially what we're starting off with is x cubed minus 2x to the power of 4 plus x to the power of 5. Standard definite integral again, with the limits of 0 and 1. So it's definite integral again, almost done the exact same way, just 1 power up of x more, okay, 1 degree more. So x to the power of 4 minus 2x to the power of 5 over 5 plus x to the power of 6 over 6. That's the result of our integration, okay. We know that k here is equal to 30, so really just leave that out until we're ready, okay. So we have 1/4 minus 2 over 5 plus 1/6. So when we use just to sort of rearrange it algebraically so we can make it a bit clearer, so have it just everything as a in terms of denominated by divided by 60. So we get 15 over 60 minus 24 over 60 plus 10 over 60. Essentially that's 1 over 60. So the expected value there is 1/2. And actually, if you saw that, if you were looking at the graph there previously, this little plot here, you might notice that it's symmetric, okay, and that therefore that would be about right. Just judging it, that would be halfway between the two, 0.5. That's not how you do it each time. It just remark that this is symmetric, okay. So when a plot is symmetric, it's essentially the halfway point, essentially, is the expected value. That correctly is the median, really. Okay, that's what you're looking for mostly when you judge it like that. So what we're going to do now is find the expected value of x squared. Now the reason for that is we will use this to calculate the variance later on. So this is an intermediate step that we have to use. So it's very like this last two calculations that we've done. In this case, what we're using now is x squared times f of x, okay? So in the last case it was x, now it's x squared times f of x, the probability density function. So essentially just working this out the same way, so so we have x squared times x squared, okay, we'll just simplify that as x to the power of 4, multiply it through, we get x to the power of 4 minus 2x to the power of 5 plus x to the power of 6. When we integrate that, and again the 30 is out here on its own, we'll just leave that until the end. So when we integrate x to the power of 4, we get x to the power of 5 over 5. Minus 2x to the power of 5, we get minus 2x to the power of 6 over 6. And here x to the power of 7 over 7, that is the integral of x to the power of 6. So again, just using the limits of integration, 0 and 1, okay, evaluate it out, we get 1/5 minus 1/3 plus 1/7, and essentially what happens there is that should work out to be 2 over 7, okay, so that is the expected value of x squared, okay. So this is a very important formula that you should be familiar with, okay, how to calculate the variance of x. And essentially this is why we done that intermediate step to calculate the expected value of x squared, that part there, because we needed to calculate the variance. So the expected value of x squared minus the expected value of x to be squared, we just verbalize that the slightly different ways, or two different quantities, okay. So we have 2 over 7, which is the expected value of x squared, and the expected value of x multiplied by itself, essentially, or squared, is 1/2 over 2. So this works out to be, when we calculate it out, it works out to be 1 over 28. Great. Now, so we'll finish up on this part here. No, we won't. We leave it there and we will move on to the next part here. We'll pick it up here shortly.